Good day everyone, welcome to my final year project. My name is Tay Ziyang with ID AA16171 under the surveillance of Dr. Chen Hong-Tian. My topic for final year project is design of steel frame for 6 stories shopping mall using ANSYS. As you can see, this is my model. First of all, the introduction. High-rise buildings are increased rapidly around the world due to the speedy increase of urban population and cities. Finite element analysis is a handy tool for solving complicated problems of numerically approximating physical structure. We replace it to an analytical solution. The problem statement. High-rise building analysis consists of many levels and issues. Difficulty of analysis of 3D steel frames compared to 2D steel frames. Next, the objectives. To analyze the simulation under various loads to the steel frame in process with different outcomes of probabilistic methods. To achieve the maximum diffraction of steel frame under various variables using response surface method. The scope of study. Suitability of my steel as material. Stability of steel frames. The following is literature review. The author, Brady L.S., Mill M., Ali, Armstrong P.J. The scope they study, the skyscraper and city design technology and innovation. They describe that the need for lighter and more efficient structural material to build higher structure is now obvious. Iron was considered to be alternative. Moreno and Gradible, Monteagudo, Maya. The scope they study, high-end solution for advanced civil engineering projects. They describe that CivilForm is civil engineering exclusive software that integrates with ANSYS for simulation of design and checking. Cypress. The scope they study, what is their different type of finite element analysis. They describe that model analysis is a study of fundamental vibration modes for an object or system. Gunz. He studied that response surface approximation for pitching movement including pitch up in the multidisciplinary design optimization of a high-speed civil transport. He described that response surface method helps to reduce the costing of the analysis, such as cumulative distribution function analysis and associated numerical noise. And through F-Siegel, the scope he studied, the cumulative distribution function displays the percentiles. He described that the cumulative distribution function is a plot of the data specifically designed to show the percentile by plotting the percentage against the data value. Ray, Stefan, Willy, Lin, Daniel, Mukherjee, Siddhartha, Kaur, Hui. The scope they study, probabilistic finite element analysis using ANSYS. They describe that as such the probabilistic distribution function is completely independent of the physics captured in an finite element analysis for instance cover the range for a typical linear elastic stress calculation to a progressive coupled multi-physics analysis. Besides the methodology part, for the methodology we have 3 phases. First is pre-processing, second is solution phase, and the third one is post-processing. For the pre-processing, we set the codes and units, define element types, define material, define section, define member properties, define beam and shelf properties. Then we define key points and elements, creating of model. For the solution phase, we apply constraint, apply loads, and click solving for the solution. For the post-processing, the reaction force, displacement force and moments, and lastly for the code checking. For the code checking, we have tension, compression, bending moment resistance, shear resistance, bending and shear force, bending and shear force, bending, shear force and shear force, compression buckling, lateral torsional buckling, and bending and compression buckling checking. Lastly, we come to the result and discussion part. The random input variable we put for the point load is negative 50,000, wind load is 10,000, Poisson ratio is 0.35, elastic modulus is 2.1 to the 10 to the power of 11, density is the 7,850, temperature is 200. And the statistic of random input variable for the standard deviation, the value is here, skewness, kurtosis, minimum and maximum value. This is generated by the ANSYS, and the sample value for output parameter maximum diffraction is shown at here, which simulate 10,000 times. For the histogram, the point load, the minimum value is negative 1.2459 10 to the power of 5 kilonewton. Maximum value is 3.1523 10 to the power of 4 kilonewton. And the following is density, modulus elastic, Poisson ratio, temperature, and wind load. For the PDF and the CDF graph, as you can see, all is look like similar. The point load value, the minimum is negative 110 kilonewton, maximum is negative 50 kilonewton. This is the density value, the modulus elastic value, the Poisson ratio value, and the temperature value, the wind load, and lastly the wind loads value. The CDF graph, the point loads, seems the minimum value is negative 110 kilonewton, maximum is negative 50 kilonewton. The density value is here, the modulus elastic value, Poisson ratio value, temperature value, and wind loads value. For the sensitivity plot, this is the linear correlation. For the linear correlation, you can see the blue-green color is a Poisson ratio, while the pale green color is a point loss. These two show the significant sensitive for the linear correlation sensitive result. For the rank order, it shows same to the linear, which is the Poisson ratio and the point load value are too significant, while the rest is less significant. Here we come to the response survey plot. As we can see, for the density versus modulus elastic, the maximum deflection value calculated from the equation of ANSYS is 2.63051 10 to the power of 9 millimeter, and the density versus point load is here, the value. The density versus Poisson value is here. We have about 15 different graph with the two different variables. Next, we can see the different. Okay, this is the density versus temperature, the density versus wind load, modulus elastic versus point load, and the modulus elastic versus Poisson ratio, the modulus elastic versus temperature, the modulus elastic versus wind load, the point load versus Poisson ratio, the point load versus temperature, the point load versus wind load, and the point load versus temperature, the Poisson ratio versus wind load, the temperature versus wind load. For the conclusion, the objective of result analysis in ANSYS with different probabilistic method outcome are achieved. The result of analysis are affected by some input variables. For the recommendation, we provide more significant inputs. We test different shape of course section, increase the amount of study materials. That's all from me. Thank you.